Hey everybody, this is a video for 921 Solving Inequalities Practice, which is work we did in class on last week of April. So for those of you who missed class that day, I'm just going to do this video to help you kind of go through what we did, what we talked about, what we covered, so that you're not as confused, hopefully. So some pretty basics. I figure you can probably do 1 and 2. I'm just going to work through number 2. So I'm going to distribute. And I get negative 3 plus 21n equals 5n minus 35. Then I'm going to subtract 5n from both sides. And I get negative 3 equals 2 plus 16n equals negative 35. Add 3 to negative 35, and 16n equals negative 32, divide by 16, and n is negative 2. No big deal. So why bother? Well, so that we can remember something very straightforward and relatively simple. And that is how to solve these. So they're a little tricky and a little more difficult, mostly just because we're out of practice more than anything else. But whenever you see the word inequality or you notice the symbol, the first thing you want to do is not let the screen go blurry. And then after you're done making sure the screen doesn't go blurry, you're going to want to pretend it's an equal sign and just solve. So I'm going to start by dividing both sides by 5. And I get negative 3x minus 7 equals, again, I'm pretending that's an equal sign, negative 25. I do not like that all these numbers are negative, so I'm going to change all of them to positive numbers. I do that mathematically by timesing everything by 2, negative 1. But I have to get every single term, and I can only do it if I change everybody. It just makes it easier. I can do the math easier. It's simpler for me. Minus 7 from both sides, 3x equals 18, divide by 3, and x is 6. Then, for this one, with this one, I can, if I distribute, I'm going to get big numbers. Oh wait, I'm not finished. I forgot what I was doing. We do need to test stuff. So what we know right now, so this, we pretended it was an equal sign. I'm sorry, I completely forgot what I was doing. We pretended it was an equal sign, but we do need to solve it still, because it was an inequality. We're going to graph its solution. 6 is my number. 6 is the number that makes both sides of this equal. So when they're equal, well, it won't be a solution because it just says less than only. So that's an open circle. And I need to decide, are my answers on the left of 6 or the right of 6? Now there's a lot of rules when solving inequalities that we screw up. So I don't like to play with any of those. I just like to test always. I'm just going to test a point. Over here I'm going to test 0. And over here on this side I'll test 10. I'm going to start by testing 0. And all that means is I'm going to plug 0 in. When I plug 0 in, I get 5. The outside. That becomes 0. Minus, so negative 7, which is negative 35. We want it to be less than negative 125. And this is not. So I know that if the negative signs weren't there, it would be true. But with the negative signs, it's backwards. So this is false. And so my answers are not on that side. Then just to be sure, I'm going to test 10. I will get 5 times negative 30, 3 times 10, negative 3 times 10, minus 7, which is 5, times negative 37, which is negative 185, which is smaller than negative 125. So this is true. And so my answers are this side. You can either do an arrow like that, or you can scribble on the line. Just make sure that if you're drawing on the line that it's clear, that it's there. That's why I scribble and don't just draw another line on top. And that's all we're doing. So when we're dealing with inequalities, what we're doing is going through the motion, going through that basic idea. So number 4, I'm not going to divide by 6. The reason I could divide by 5 is 5 goes into 125 and therefore makes the problem easier. but 6 does not go into 20 or 5, and so dividing by 6 will make this problem harder. So I will distribute on this problem. 6, and I'm going to use capital B. My lowercase b looks too much like a 6, plus 2, which is equal to 20 plus 5b, minus 5b from 6b. Can't be consistent though. And so I get b plus 2 is 20, and so b is 18. Now again, this is just the boundary. Is that right? Oh, no, I did it wrong right here. 6 times 2 is not 2. It's 12. I can't remember this answer. So it's 12. When I minus 12 from 20, I get 8. I remember that answer. So now I'm drawing it on my number line. 8. Now remember, 8 is the number that makes both sides equal. And since this says or equal, 8 is an answer. Okay, so 8 is an answer. Now we're going to test our numbers. Again, on the left, we'll test 0. On the right, we'll again test 10. We're really boring like that. It's more fun to be consistent. Actually, it's mentally easier. I'm going to test 10 first this time, just for fun. I get 6 times 12 is less than 20 plus 50, which is 72, is less than 70, which is false. Then I'll test 0. 6 times 2 is less than or equal to 20, because the b's are going to be gone. And so that's 12 is less than or equal to 20, which is true. So my answers are over here this time. That's it. That's all there is to it. Okay. So that's what I thought it was. Let's go ahead and jump down to these last two. So these last two are a lot trickier than the others because of the absolute values. But absolute value is fairly simple. What we have to kind of keep in mind that this means how far away from 0. So if I said something like this, what number is 2 spaces away from 0? Well, there are 2 answers. X is either 2 or negative 2. The absolute value removes the sign of the result. Not signs anywhere else, but it takes the sign off. When you take the sign off, a positive 2 you can't tell, negative 2 you can, it takes the sign off. So what I know is I have these two equations. 6x minus 5 is 53, or 6x minus 5 is negative 53. And you should expect to get decimals from these. That's really straightforward. Well, this one. It's very rare. It's very difficult to make them both come out nicely. So usually we just don't bother. And one of them will come out nice and the other will be ugly. So just kind of, that's pretty typical of these problems. And nothing to be concerned about. For this one, I'll have these two questions. Either it's 19 or it's negative 19. And this time I will not get fractions, but that's because n does not have a number in front of it. And just solve those. No big deal. I'm going to leave those for you to do. But it's no big deal. You're expecting 2 answers, and that's your basic idea. So let's go ahead and jump to the next set of problems. And so now we have them as inequalities. So again, the first thing I do is pretend it's an equal sign. And if it's an equal sign, I will end up with 2 equations. 9 plus 9x is 9, or 9 plus 9x is negative 9. So 9x is 0. I subtracted 9 from both sides, which makes x 0, because 9 times what number is 0? X is 0. That's one of my 2 boundaries. Leave those there so that it doesn't blur up as much. It's not working. We subtract 9 from both sides here. We've got 9x is negative 18. Okay. And so then I divide, and x is negative 2. So now I'm going to draw my boundary, my line. I've got a number at 0 and then negative 2. So now I have 2 boundaries. Both numbers are open because these are the numbers that make it true, equal, and we only want it to be smaller. And so now we need to figure out, are my answers here in one of these 3 areas? 1, 2, 3 areas. So over here, I will check -10. Inside here, there's not a lot of numbers that are nice. So I'm going to choose -1. And over here, we'll choose +10. We cannot choose 0 because 0 is one of my numbers, one of my boundaries. Okay, so I'm checking -10. When I put -10 in, I get 9 plus -90, which is -81. The absolute value is 81. 81 is less than 9. No, so that's false. I'm going to check +10 here because all I have to do is go like this. Then it becomes 99, which is not less than 9. So that's also false. See how I just kind of fake that right there. Then for the green one, check -1, I get 9 and -9, which is 0, and 0 is smaller than 9. So that one's true. And my answers are in here. You can do it like that or like this, whichever works for you. That's all there is to it. I'm going to leave 8 for you. And let's jump down to 9 and 10. So 9 and 10 are quadratic. We're going to try to factor. So we're going to build our box. And our x squared goes here. 42 there. 42 here. -13 there. Numbers that multiply to make 42. 1 and 42. 2 and 21. 3 and 14. 5 no. 4 no. 5 no. 6 and 7. 6 and 7. Both negative. -6x, -7x. And x -6 and x -7 is 0. So my x equals 6 or 7. Okay. For number 10, we'll use the quadratic formula. A is 3, B is 8, C is 4. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. X equals -8 plus or minus the square root of 64 minus 48 over 6. X equals -8 plus or minus the square root of 16 over 6. -8 plus or minus 4 over 6, which is -4 over 6. -8 plus 4. -8 minus 4. So x equals -2/3 or -2. And those are my answers. Now this was factorable, but I didn't want to think about it, so I went into the quadratic formula. This was factorable. On both of them, I could have swapped methods. It would have worked out. It's just a matter of what I want to do. Now, before we move on to the last 2 problems, I want you to look carefully at 9 and 11. And the only difference is the inequality. And 10 and 12, and the only difference is the inequality. Which means I've already pretended it was an equal sign, and so I can just start by trying to graph. Start with my boundaries. So this one, my boundaries are 6 and 7. Okay. My boundaries are 6 and 7. Okay. And since it says or equal to, these are filled in circles. And then I'm going to test some numbers. I'm going to start by testing 0 over here. I'll put 6.5 in the middle, because that's only one number in the middle. And then I'll put 10 over here. Let's go start with 0. 0, 0. 42 is less than 0. False. 10, 100 minus 130 plus 42, which is -30 plus 42, is less than 0. That's going to be positive, so false. That F does not look like an F on the previous problem. No, it does. Not really. So that's also false. And then 6.5. Okay, using a calculator. Six 6.5 squared is 42.25. 13 times 6.5 is 84.5 plus 42. And so this gives me 42, negative 42.25 plus 42, which is negative 0.25. And so that's smaller than 0. So yeah, that one's true, and my answers are in here. Okay. So then for number 12, my numbers are negative 2 and negative 2/3. They're both open circles because it says strictly greater. I'm going to test 0. 0 plus 0 plus 4 is bigger than 0. Yeah, 4 is bigger than 0. True. I'm going to test negative 1, which is 3 minus 8 plus 4, which is negative 1, which is not bigger than 0. Then I'm going to test over here, how about negative 10, which is 3 times 100 minus 80 plus 4, which is 220 plus 40, no, not 40, just 4, which is bigger than 0. And there you go. And, oh wait, I didn't do it on any of them. I'm sorry, the answer written for this one will be x is between or equal to 6 and 7. For this one, x is less than negative 2. X is greater than 2/3 together, and that's your idea. So good luck. I hope you enjoy it. I will see and talk to you guys soon. Have a great day.